Okay, so the floor now is for Erica.
I completely changed the topic. I'm going to talk about temperate fruits and how can we phenotype the agroclimatic requirements in order to adapt to the challenges of global warming. Oops. First of all, I work at 𝐍𝐞𝐰, is in Aragon, here in Zaragoza, and it's a research center that depends on the regional government of Aragon. When I'm talking about temperate fruit trees, I talk about stone fruit as sweet cherry, apricots, and plum, but also as pit fruits as apple and pears. Just sort of reminder, what we see in an orchard are clones, and so just one individual, or sometimes we perhaps see two to guarantee pollination. But and the process to produce a new cultivar in temperate fruit trees is, let's say, quite simple. You select the parents, then crossing, then you put in the field all the offspring, phenotype them with different techniques. You can do a first selection, and finally you select the cultivar that you really want. This that is, well, let's say, quite simple. It can take in temperate fruit trees at least 10 years. And if you wanted to phenotype characters as flowering or fruits, you need to wait the tree till the tree overcome the juvenility. So this is at least 4 years. So we really need in temperate fruit trees advancing the way of phenotyping, early phenotyping in characters that we can identify with well, in genetics and that we really have the markers to facilitate and so on. So what's happened with temperate fruit trees, how we can adapt a crop that is in the field for years, or at least 15 or 20 years in the field, and to face the challenges that global warming are showing us. One of the main, one of the important effects that is having the rising of temperature is the decrease of chilling accumulation during the winter. It sounds we are like extremely worried about a heat wave in the summer, but the loss of chill in winter is really threatening the viability of these orchards in the Mediterranean area. This is because the temperate fruit trees synchronize the phenology to the seasons. They flower in spring or late winter, and to have this flowering and fruits during the suitable seasons. But if we look but to survive to the let's say the bad conditions during the winter, they enter into a dormant state. During this state, they need to accumulate or to be exposed to low temperatures to be able to bloom with normality, let's say, to have a good bloom and being able to develop fruit in a spring. And one of the main and limitation if we don't have tools to phenotype this. This is a character that is genetically regulated and is cultivar specific, but difficult to phenotype. To see how global warming is affecting winter chill, this is the evolution of winter chill in Zaragoza. This is a cold area, and we are having, and the chill portion is the unit that we use to calculate the accumulation of chill that is effective for the trees, and we are having significant decrease of winter chill. If we pay attention worldwide predictions, if you see here, just mention look at the Mediterranean area, the winter chill losses that are predicted are extreme. Here in this work, what we did in collaboration with Moroccan and Tunisian colleague, if you see the loss of chill in these countries in the north of Africa, reach 40 chilling portion. That is almost all the chill that they accumulate during the winter. So this means that these crops are not longer able to to be possible to be cultivated there. And they are now facing this problem as well as in Spain and in the south part of Spain. And here in the Ebro Valley, that we are like quite in the north part, we are going to, is predicted to lose by the end of the century between 20 and 30. That this means that all the cultivars that are growing now, they are not going to be viable in the future. So what's the main problem is that the till accumulation, once the buds are able to grow, there are not any change, and we really know little about the physiology of this process to detect when they have accumulated enough till. How do we phenotype this character? We use like quite old techniques like sample shoots, putting them into a growing chamber and evaluating when the buds are able to respond to this worm treatment. And then we can see that this tree have accumulated enough till. There are other methods like statistical methodologies that we analyze long phenological records, let's say flowering dates of 20 years that we relate with the temperature during the winter. And then we statistically analyze and we establish the period of chill and heat accumulation. Once we have established these requirements for flowering, we use different models to quantify the temperatures, the chill and the heat. Currently, there are very, very little information on the agroclimatic requirements of the current cultivars that are cultivated, and my work now is working with my team is on phenotyping the new cultivars and also predicting the adaptability to future conditions in different regions. As we see here, these cultivars that are flat, let's say flat pitches, will behave well in Caspe in the future in Zaragoza, but in Badajoz, some of the cultivars will face some problems in the future. And yeah, and now we are trying to offer information about this character in the available cultivars of the different crops. But what happens with when you wanted to develop a breeding programs with this taking into account this character? The method I described, they are not useful. In one hand, the empirical one requires a lot of plant material, a lot of labor, infrastructure is not feasible, and the statistical one, let's say we can wait 20 years to get to have a phenological data set. So other part, what we are trying to approach is trying to understanding a little bit more about the biology of this process. And we are and also looking for biomarkers in order to see if there are some indicator that could give us a key and to characterize, to phenotype this trait. I work with flower development. It's a very well-known process that's occurring in parallel and closely related with dormancy. So a success story is that the male meiosis in apricot occurred just after till accumulation. So it's a very good biomarker to characterize this trait. And we have validated with different techniques, and so it's ready to use, and we are applying that for apricot cultivars. But it's not a universal, and different species have different synchronization of the flower development with dormancy. Other candidate that we are working with is the stats accumulation in flower development. Stats accumulation and depletion occurs all along the flower development, and we are trying to relate this with the temperatures that occur during dormancy. This is a work in progress, trying to develop a technique to easily characterize these stats waves in order to to find a character related with the 𝐬𝐶 accumulation. And well, and we are also keeping open. Well, we keep our eyes open to see for looking for more processes and that could give us an idea of what's happening during dormancy in temperate fruit trees. And yeah, that well, and I know this is like a quite a descriptive word, but it will be great. There are a lot of information on the well, there are a lot of works on the genetic regulation of dormancy in temperate fruit trees, but there's not a let's say a ready-to-use tool or a really knowing pattern of what's happening and in terms of the genetic regulation of this trait to really apply genetics tools to know how they are going to behave under different winter conditions. And yeah, I would like just to give some take-home messages, as that the global warming is threatening our survivability in the Mediterranean basin, and one of the solutions to guarantee the temperate fruit production in the Mediterranean, that is they're really important crops because of their high added value, is breeding programs and genetic. But we need to improve the how to phenotype the agroclimatic requirements in order to predict the capacity to adapt to future climatic conditions, and also go deeper in the understanding of the biology of dormancy to easily phenotype this trait. Thanks for your attention.
Thank you very much, Erica. Erica, thank you very much for the presentation. Okay.